Okay, here we go. This is a calculator problem and it's an accumulation problem. So we're talking about penguins here and we're given two rates of change, okay? So the first rate of change is the births per year. And then the second rate of change is the deaths per year. And we're given a closed interval from 0 to 40. And we're given 1 point that initially at time 0 that there were 100,000 penguins. Okay, now let's answer the first question. So part A says, what is the rate of change of the penguin population? So the whole population on the island at time t equals 0. So basically we're going to go b of 0 minus d of 0. Now, key point here. Since you're given two functions, quite complicated, the first thing I would do is I would go to my graph mode, and in f of 1, I would type in that first equation. So 1000 e to the 0.06x. And then I would type in f2 in the graphing mode, 250 e to the 0.1x. So anytime I'm given an equation like this that's complicated and I know I'm going to use it more than once, I type it into the graphing mode so I can use it in my calculator. So you can see here then when I did the calculator, to get this, I pressed the var button. Okay, that's your variables. And then under var, I pick F1 at 0. And then I minus, and then the var button again, but this time I choose F2 at 0. And the answer is 750 penguins. So this would be 750 penguins per year is the rate of change. Part B. Now part B says to the nearest whole number. Now a lot of you did much better this time on that. What is the penguin population at time t equals 40? So we want to know the amount of penguins. So if you're given a rate of change, then that's always, we take the integral of the rate. So you can see here on my calculator then, again, I'm going to use that F1, F2. So I want to know from 0 to 40, what is the amount of penguins plus the initial value of 100,000. So we're given this long decimal, but again, they wanted the nearest whole number. So we would say there are 133,058 penguins on the island. Okay, great. Now let's go on to part C. Oh, and by the way, for this problem here, you would get 1 point for having the limits correct on your integrand, and then you'd have 1 point for the correct integrand, and then you get 1 point for the correct answer. Okay. Now, part C says to the nearest whole number, what is the average rate of change? So basically, we want our answer to come out in the units, penguins per year. Okay, now we have two ways of doing this to find average rate of change. So we could do the integral of the rate, which is b of t minus d of t, because, right, the integral of rate would give us the amount, the number of penguins, and then I would divide that by the number of years, which is 40, right? Dividing it by years. So you can see my units would be accurate then, and it would be from 0 to 40. Or the other way I can think of it, it's average rate of change. So that means we could go the total number of penguins at 40 minus the total number of penguins at year 0, all divided by 40 minus 0. Because again, we're getting penguins per year. So you could do this problem either way. If I did it this way, I would just plug that again into my calculator, f1 of x minus f2 of x. Now if I did this, we've already figured out these answers. We figured out that at P40 there were 133,058 penguins minus the 100,000 that's initially there, and then divide that by 40. So either way that you do it, you should get 826.45. So that means then the average rate of change is 826 penguins per year. So for this problem, you just get 1 point for the answer. Average rate of change is 826 penguins per year. Okay, now to the last part, Part D. Okay, now Part D, you are asked to find the absolute minimum and the absolute maximum. So we have to find both the minimum and max. Now, honestly, the key mistake here is that, again, they ask you to show the analysis. Now, that doesn't just mean show the analysis. That doesn't just mean numbers. That means verbally analyze the situation. Too many of you are still forgetting to verbally express your mathematics. Okay, to find an absolute minimum or maximum, so we might say a sentence here that, here, let me give myself some space here. Okay, I'm going to erase this. Sorry, it takes a little while to erase here. And I know if I don't get all the bits, that will just drive some of you crazy because you just got to have all the little white bits erased. I know. Okay, absolute minimum, maximum, okay, whoops, is calculated, sorry, by, absolute minimum, maximum is calculated by finding the values at the endpoints and critical points. So here I'm addressing the prompt of finding maximums and minimums, okay? Now, to find critical points. In order to find a critical point, I set the derivative equal to 0. So in this case, it is the births minus the rate of deaths equal to 0. Okay, I'm earning a point right there by showing that work. Now, when doing this on the calculator then, what I will find is t would equal, now again, make sure your calculator mode is set up correctly, that it's on float, because you should be getting a decimal looking something like this, okay? And I encourage you not to round your decimal until the very last step. So here we go, t equals 34.65739 is the critical point. Now, let's see, where's my absolute maximums and minimums? So we have t that we're analyzing, and we have the amount of penguins. So at 0, we know we're given that there's 100,000 penguins. And at 40, we've already calculated there's 133,058 penguins. Now you can see here I have my calculator notation finding the number of penguins at 34.657359. And when I do that, so 34.657, the amount of penguins is 139,167. So the maximum then is occurring there. So now I would write my sentence stating that the minimum population is 100,000 at time t equals 0. Now notice they asked for the population. They didn't ask when. They asked for the population. So you would have to state that. And then the maximum population, oh dear, I'm going to run out of room, is, and then I would complete my sentence, 139,167 penguins at time t equals 34.657. And what is the units again? Years. Okay, so there you go, is your complete answer.